Imagine waking up every morning in a place where the sky never cries, where rain is so rare that children grow up without ever knowing the sound of drops striking a rooftop. Now imagine that in this very same place millions of people turn a tap, and the water simply flows. How is that possible? Where does the water come from in a land where rivers do not exist and the sun scorches everything it touches? The answer lies buried beneath the sand. Kilometers upon kilometers of steel arteries, invisible to the world, carrying liquid life through the most hostile void on the planet. This is not science fiction. This is happening right now as you listen to these words. If this kind of content pulls you in, if you want to understand how human engineering challenges the limits of nature, subscribe now and activate the notification bell. You will not regret it. Now let us get straight to the point. To understand the magnitude of what is happening, we must first understand the starting point. We are talking about a territory that covers an area comparable to several European countries combined. A place where summer temperatures rise above 50 degrees Celsius. Where humidity is almost an abstract concept. Where rivers, lakes, and surface water flows practically do not exist. For centuries, survival depended on something hidden beneath the ground. Fossil water reserves. Aquifers formed thousands of years ago, when this region was green and humid. That ancient liquid allowed oases to flourish. It made it possible to grow wheat in the middle of the desert. Entire communities built their lives on an invisible resource. But there was a problem. A massive problem. That water did not renew itself. Every liter extracted was 1 liter gone forever. And when the population began to grow, when cities expanded and industry demanded more and more resources, aquifer levels started to drop at an alarming rate. The ground itself began to sink in certain areas. Wells that once provided abundant water started to dry up. Farmlands that had fed generations turned into dust. The crisis was not a future possibility. It was a reality hitting with full force. At that moment, the leaders of this nation faced a decision that would define the fate of millions of people. They could accept scarcity as an inevitable destiny, limit growth, restrict consumption, resign themselves to decline, or they could attempt something never done before at this scale. Create water where none existed. Manufacture it. Extract it from the only abundant resource within reach, the sea. And they chose the second option. What followed became one of the greatest engineering feats of the modern world. Along the coastline, gigantic desalination plants began to rise. Industrial complexes capable of drawing in millions of liters of seawater every single day, processing it, and converting it into drinking water safe for human consumption. Some of these facilities can produce more than 1 million cubic meters of fresh water daily. To put that into perspective, that is enough to fill 400 Olympic-sized swimming pools every 24 hours. From a single plant. And there are dozens of them. The process begins offshore. Massive intake pipelines pull seawater from the ocean through grids and filters designed to trap debris, algae, jellyfish, and any organism that could contaminate the system. That cloudy, salty water then travels toward the coast, where it enters a series of sedimentation tanks. Here, heavier particles sink to the bottom by gravity. Next comes sand and gravel filters, which remove finer impurities. After that, ultrafiltration membranes capture microorganisms and microscopic particles. All of this happens before the water reaches the heart of the system. Reverse osmosis. This is the critical moment. Imagine thousands of pressure tubes, each containing semi-permeable membranes with pores so small that only water molecules can pass through. High-powered pumps force the salt water against these membranes at pressures exceeding 60 bars. Under that brutal force, pure water passes through the barrier, while salt and minerals remain trapped on the other side. It is a process that defies the natural laws of diffusion. Nature seeks balance. Here, technology forces it to do the opposite. But this miracle comes at a cost. A massive cost. To produce a single cubic meter of fresh water, between 3 and 4 kilowatt-hours of electricity are required. A large desalination plant consumes as much energy as a small city. We are talking about millions of kilowatt-hours every day, used solely to generate drinking water. For decades that energy came from oil. Burning crude to create water. A brutal irony in a land floating atop an ocean of hydrocarbons. And here is another detail few people know. The water that emerges from reverse osmosis is almost completely stripped of minerals. It is too pure. It sounds contradictory, but the human body needs certain minerals dissolved in water to function properly. Calcium, magnesium, essential trace elements. That is why, before distribution, the water goes through a remineralization process. Specific compounds are added. The pH is adjusted. It is disinfected using chlorine or ultraviolet light. Only then is it ready to travel. And this is where the story becomes truly epic. Having water at the coast does not solve the fundamental problem. The major cities, the political and economic centers, the most important population hubs, are located deep inland. Hundreds of kilometers away from the sea. Separated by relentless deserts, mountain ranges, and terrain that seems designed to block any kind of construction. Delivering water there required building something that can only be described as a national-scale artificial circulatory system. More than 14,000 kilometers of steel pipelines buried beneath the sand. Think about that for a moment. 14,000 kilometers. That is farther than the distance from Madrid to Tokyo. Pipes nearly 2 meters in diameter. So wide that a full-grown adult could walk upright inside them. Made from high-strength steel, engineered to withstand extreme internal pressures and the brutal thermal fluctuations of the desert, where the temperature difference between day and night can exceed 40 degrees. Each section of pipe is coated with multiple protective layers. On the inside, materials safe for contact with drinking water prevent corrosion and the buildup of deposits. On the outside, anti-corrosion coatings protect against salt, abrasive sand, particle-laden winds, and ground temperatures that can exceed 60 degrees. Many segments are buried several meters deep to minimize exposure to surface heat and to protect the lines from mechanical damage. The construction of these arteries was a military-style operation. Corridors dozens of meters wide cleared through the desert. Survey teams using GPS and laser equipment traced precise routes, avoiding unstable geological formations and impossible slopes. Specialized excavators opened trenches stretching for kilometers. Cranes lowered pipe segments weighing tens of tons. Welding crews worked beneath a sun hot enough to melt metal, joining each section with millimeter-level precision. And here is the detail that keeps engineers awake at night. Every weld is a critical point. Under the operating pressure of the system, the smallest defect, a microcrack invisible to the naked eye, can turn into a high-pressure jet capable of eroding the surrounding soil and destroying entire sections of the line. That is why every joint is inspected using non-destructive testing techniques. Industrial ultrasound, radiographic imaging, pressure testing. Only after passing all inspections is a segment authorized to be buried and construction allowed to continue. But pipelines alone are not enough. Water does not move by itself across hundreds of kilometers and uphill. Force is required. Raw power. Along the main routes, pumping stations are strategically spaced. Each one houses massive pumps capable of pushing millions of liters per hour against gravity and friction. Some lines cross mountain ranges, lifting water from sea level to plateaus more than 1,000 meters above it. A titanic effort repeated every day, every hour, without rest. And here, another invisible enemy appears. Water hammer. When high-speed water flow stops abruptly, due to a power outage, a valve failure, or any sudden interruption, a pressure wave is generated. It travels through the pipe like a contained explosion. That wave can multiply normal pressure several times over, subjecting pipe walls to stresses they were never designed to endure. To counter this, the system includes surge tanks and relief valves distributed along the lines. They act as shock absorbers, absorbing the energy of the surge before it causes catastrophic damage. Now multiply all of this by thousands of kilometers. Hundreds of pumping stations. Dozens of intermediate reservoirs. Millions of connection points, valves, sensors, joints. Controlling a system of this complexity using traditional methods would be impossible. That is why, running parallel to many of the pipelines are fiber optic cables. They do more than transmit data. They act as distributed sensors, detecting vibrations, temperature changes, and abnormal sounds. An unauthorized excavation near the line, a landslide, an emerging leak. Everything generates signals that the system captures and transmits to control centers. Inside those rooms, engineers watch digital representations of the entire network. Maps where every green point means normal operation, and any anomaly triggers immediate alerts. Artificial intelligence processes the data in real time, identifying patterns, predicting failures before they happen, optimizing the energy consumption of the pumps. It is an artificial nervous system spread across an entire nation. And all of this comes at a price. A brutal price. The first desalination plants produced water at a cost of more than $1 per cubic meter. With current technologies, that cost has dropped to between 50 and 70 cents. It is still far more expensive than water from rivers or lakes. But there are no rivers. There are no lakes. The alternative is thirst. The alternative is collapse. That is why this nation is investing billions to transform the system. Solar energy to power desalination plants. Wind turbines along the coast. Green hydrogen projects to store clean energy. The goal is clear. To decouple water production from dependence on oil. To make every drop not only drinkable but sustainable. And there is another front in this battle. After reverse osmosis, a residue remains. Highly concentrated brine. 4 years, it was discharged into the sea, damaging coastal ecosystems. Now, researchers are exploring ways to extract value from that waste. Magnesium for lightweight alloys. Lithium for batteries. Industrial salts. What was once pollution becomes a resource. What was once a loss turns into gain. When you look at the full picture, you realize this is not simply an infrastructure project. It is a declaration of war against geography. An existential gamble. Buying water from other countries would mean dependence. On foreign decisions. On political agreements that can break. On transport routes that can be cut. In a region shaped by tension and conflict, that dependence would be an unacceptable vulnerability. That is why every dollar invested in this system is a dollar invested in sovereignty. In survival. These steel pipelines buried beneath the sand do not carry only molecules of hydrogen and oxygen. They carry the future of millions of people. The possibility that cities can continue to grow where logic says no one should live. The promise that human will can bend even the most unforgiving deserts. We live in an era where water is becoming more valuable than oil. Where entire nations face droughts that once seemed unthinkable. Where climate change threatens sources we believed were secure. What is happening in this corner of the world may be a preview of the future for all of us. A model to study. A warning. Or perhaps a hope. Can this strategy be replicated elsewhere? Does it make sense to invest so much just to have water? Or is it the only way forward for a planet that is slowly drying out? Let me know what you think in the comments. Your opinion matters more than you think. And if you made it this far, if this journey through rivers of steel beneath the sand made you see the world differently, do something simple but powerful. Like this video. Subscribe to the channel. Activate notifications. That way you will not miss the next stories of extreme engineering that are reshaping our planet. Thank you for your time. See you in the next video.